Good day, everyone. My name is K Nagaraju. I am a lecturer in zoology at Srimati NPS Government Degree College for Women, Autonomous, Chittor. Today, I will be explaining the topic of Municipal Solid Waste Management. This topic is important for understanding environmental protection, public health, and sustainable development. In this session, we will discuss how municipal solid waste is generated, stored, collected, transferred, and managed in an organized and scientific manner. Let us begin with the waste generation and storage at the source level. Municipal solid waste is generated from a variety of sources. The largest share comes from households. Other sources include commercial establishments such as shops and markets, institutions like schools, offices, and hospitals, excluding biomedical waste and waste from street sweepings and public spaces. At the source level, proper storage of waste is essential. Waste should be stored in a manner that prevents littering, bad odor, and the breeding of insects or rodents. Segregation at the source is strongly recommended and is mandatory in many countries. Biodegradable waste, also known as wet or organic waste, is separated from dry recyclable waste. Domestic hazardous waste such as batteries, bulbs, and sanitary waste is stored separately. All waste is kept in suitable bins, bags, or containers designed for safe handling. The next stage is waste collection. Waste collection is the most visible and also the most expensive stage of municipal solid waste management. One common method is door-to-door collection, which is considered the most effective approach. In some areas, waste is collected through community bins or communal containers. Curbside collection is also practiced, where residents place waste outside their homes at a fixed time. Waste collection systems are usually divided into two levels. Primary collection involves moving waste from the source to a nearby collection point using hand carts, tricycles, or small vehicles. Secondary collection involves transporting waste from the collection point to a transfer station or processing facility using trucks or compactors. Several factors must be considered for efficient waste collection. Wet waste should be collected daily to avoid odor and health issues. Segregation compliance at the source is critical for effective processing. Route optimization helps reduce fuel use and operational costs. Worker safety and mechanization play an important role in improving efficiency and reducing health risks. When processing or disposal sites are located far from collection areas, waste transfer and transportation become necessary. Municipal solid waste processing begins after waste has been collected from households, commercial establishments, and public spaces. Once a collection vehicle arrives at the processing facility, it first stops at the weight bridge. The vehicle is weighed to record the total quantity of waste entering the plant. This information is essential for daily monitoring, planning, and performance evaluation. After weighing, the vehicle moves to the unloading area. The waste is unloaded onto a large concrete tipping floor designed for safe handling. At this stage, trained personnel visually inspect the waste. Large, bulky items such as furniture, tree branches, or oversized debris are removed. Any hazardous or unsuitable materials are separated immediately. This inspection step protects processing equipment and ensures worker safety. Following inspection, the waste undergoes primary manual segregation. Workers spread the waste in thin layers across the floor. Large recyclable materials, including plastics, cardboard, and metal objects, are manually picked out. Inert materials like stones, sand, and construction debris are also removed. After manual segregation, the remaining waste is transferred to the size reduction stage. The waste is fed into a shredder where it is cut into smaller, uniform pieces. Size reduction improves handling efficiency and enhances further biological and thermal treatment processes. Once shredding is complete, mechanical segregation begins. The shredded waste passes through a rotating trommel screen. Smaller particles fall through the openings of the screen and are typically rich in organic matter. Larger particles move forward and mainly consist of dry waste such as plastics, paper, and textiles. Next, air classifiers are used to separate materials based on weight. Light materials like plastic films and paper are lifted by airflow. Heavier materials such as glass and stones fall downward. Magnetic separators then remove ferrous metals from the waste stream. This step helps recover valuable metals and prevents damage to downstream machinery. After mechanical separation, secondary manual sorting is carried out. Workers further segregate recyclable materials into specific categories. Different types of plastics, paper grades, and metals are separated for improved recycling quality. Wet waste mainly consists of biodegradable organic material. This includes kitchen waste such as vegetable peels, fruit waste, leftover food, and garden waste like dry leaves and grass clippings. Effective wet waste management begins with segregation at the source. Only biodegradable waste should be collected as wet waste. Once collected, wet waste is transported to the composting site. At the site, the waste is spread out and carefully inspected. Any remaining non-biodegradable or hazardous materials are removed manually. The next step is size reduction. Large pieces of organic waste are chopped or shredded into smaller pieces. This increases the surface area and speeds up microbial activity. After size reduction, the waste is mixed with the bulking agents. Bulking agents include dry leaves, straw, sawdust, or shredded paper. These materials help maintain proper aeration and moisture balance. The prepared mixture is arranged into composting units such as pits, bins, or windrows. Moisture content is maintained at an optimal level. The compost material should be moist but not waterlogged. Aeration is essential for aerobic composting. The compost pile is turned at regular intervals to supply oxygen. Proper aeration prevents foul odor and promotes faster decomposition. As composting progresses, microorganisms break down the organic matter. The temperature of the compost pile rises naturally. This high temperature helps destroy harmful pathogens and weed seeds. Over several weeks, the waste stabilizes and converts into compost. The material becomes dark in color, crumbly in texture, and earthy in smell. This indicates compost maturity. In addition to regular composting, wet waste can also be treated through vermicomposting. Vermicomposting uses specific species of earthworms to decompose organic waste. Before vermicomposting, partially decomposed organic waste is prepared. Fresh waste is not directly added. The material is allowed to cool and stabilize to protect the earthworms. Earthworms such as Eisenia fetida are introduced into the prepared beds. These earthworms feed on organic matter and convert it into nutrient-rich vermicompost. Moisture is carefully maintained in vermicomposting beds. The beds are kept moist and shaded, but not flooded. Proper conditions ensure healthy earthworm activity. Over time, the waste is converted into fine granular vermicompost.